I'm going to approach this from perhaps a perspective that many of you maybe not considered a whole lot right at the moment. But I do what's called organizational data management, and I'll sort of show you what that is. Which, there's no journal for this. There's no place for us to publish research around this. On the other hand, I hope I'm going to try to make the case to you today that it's an important topic that we need to look at, and that we really need to look at where this is housed within the university curriculum. So the subtitle sort of says it all. Data asset management requires business ownership and a less technological focus. It's not that the technology has been doing anything bad, but what I've observed in organizations that I've worked with over the years is that technology becomes a primary focus, and that's a problem. We really need to think of it as a three-legged stool with people, process, and technologies all working together to try and achieve the results that we do. A little bit about myself. I've been doing this in data management for a long time. I spent a bunch of time at the U.S. Department of Defense, where I had the title U.S. Department of Defense Reverse Engineering Program Manager. Michael Jackson was really popular in those days. They figured it had something to do with moonwalking or something crazy like that. But actually, we were starting in the DoD to get ready for Y2K in the early 90s. It was a lot of fun. I've been at Virginia Commonwealth University for the past 20 years as a professor of information systems in a business school. And in addition to that, being an entrepreneurial university, I co-own with the university a company called Data Blueprint that does this type of heavy-duty industrial consulting. Some of you may have heard VCU. We occasionally pop up into the Final Four in the basketball arena. Other than that, we tend to stay pretty quiet in Richmond. Also, some of you may have heard of DAMA International, the Data Management Association. I'm the president. I'm finishing my second term this year in January. We're going to finally have our first international president of DAMA, which is good. But there is a professional association for data managers. And again, it's not one of those things that you get a whole lot of experience in college and universities as you're working through there. Obviously, the requisite stuff that you have to go through in order to maintain your viability in the university context. And the one thing I think that I've done that's perhaps interesting to you all is that I've managed to come up with objective, quantifiable data on data management practices for more than 500 different organizations around the world. So we really can talk about what is state of the practice and what is state of the art. Now, I've got also a webinar series that runs, and I'm going to be very commercial here. It doesn't cost you a thing, but it's free. If your students want to get some additional data education, just put your name on that piece of paper and pass it on to your neighbors, and we will sign you up for these things. Again, there's not a whole lot of forum for these things. So the really fun part about what I do is I get to go spend long periods of time with different organizations. Spent about 4 years with Nokia, worked about 5 years with Deutsche Bank, and I'm coming out of 3 years with Bentonville, Arkansas. Some of you may have a knowledge of what's out there. Now, this is my actual midterm exam question that I gave my students this semester. Use the CRS database to size the market. And Dilbert says, well, we can't do that. The data is wrong. And then the pointy-haired boss, the PhD, by the way, says, then use the SIBS database. And Dilbert says that data is also wrong. And the PhD says, well, can you average them? And Dilbert says, sure, I can multiply them too. But the question for the students is, why is this the pointy-haired boss? And most IT professionals, and I really do find this is the case, have no real idea why databases can't be averaged. So I'll look at some brief historical facts, and the bottom line of the first one is that most organizations don't have repeatable data management practices. Some of you are familiar with the Carnegie Mellon CMMI model. That's how I do my measurements of these things. And that data management practices have fallen into the bowels of IT. I've got some good empirical data on that as well, which means that we have a lack of ability to make good decisions about data in this space. So there's some motivations. Obviously, we're seeing huge increases in data volumes, technological advances that are very, very cool, which means we're not going to have a short-term fix for the problem that we have. And I'll give you a little hypothesis around that as well. So I do have some remedies here that are curriculum-based, and I think that's one of the things we're trying to focus on here collectively. And it's improving a knowledge worker core that comes out of the standard ACM AIS curriculum that's in there. And another thing we need to do is we need to stop having a fiction that data and software can be developed simultaneously. And thirdly, we really need to understand that this is not an IT function, it's really a business function. I'm seeing a couple people nod their heads there, so maybe I'm not alone in that particular piece. Let's dive in. It's kind of great if we say, how are we doing in IT projects And the answer is not really well. So we see 1 in 3 IT projects that is challenged on size, cost, functionality, dimensions in there. And it is a problem. I mean, if my dentist had this bad a record, I would be looking for a new dentist. Whoops. I hit the button too soon. Hang on, let me back.
We need 3 more programmers. Use agile programming methods. Agile programming doesn't just mean doing more work with fewer people. Find me some words that do mean that and ask again.
The Air Force recently canceled a $1 billion agile program with $0 of utility coming out of it. Nothing useful came out of this project. It's not the worst. We're all familiar with this one. Of course, most of us looked at the headline that came out of this, 55 contractors. How can they possibly hope to succeed? It's an absurd proposition, correct? On the other hand, we could have just looked across the pond at our cousins, the Brits. They recently scrapped a £12 billion. That was enough money, and again, with nothing tangible coming out of this, it was enough money to pay for the salaries of 60,000 nurses for 5 years. In terms of trade-offs, it's a pretty tangible trade-off to make. Now, when we're trying to look at this and say what's going on, the real problem I find out is that most organizations don't understand data management and the role it plays in IT projects. I haven't found an IT failure that I couldn't trace back to a data problem. So we look at this diagram. This is what you don't show your management about. This is what it means to do data management. It's a very complicated diagram. This is the management version of it. There are 5 interlocking pieces. The first one is to make sure we're all managing our data coherently. The second one is making sure that when we're sharing data across boundaries, whether it's program to program, part of our organization to another part of the organization, or between our organization and our partner organizations, we need to do it as efficiently and effectively as possible. And most of the time it's simply uncontrolled, which means that we don't end up with anything going on at all. Lots of duplication. A term I wish I had coined, I did not coin this one, but much of the data is rot. It's redundant, obsolete, or trivial. So why would you make any effort into it at all? Third, until it says, Peter, your next raise will depend on the following. How much, we're going to say data quality is everybody's responsibility, which means, of course, it's everybody else's responsibility. We do have to make it personal. We do have to make it so that people understand how it works. Engineering data delivery systems is the idea, and again, we've done a disservice here because we've taught the last 2 generations of college students that the only answer is a relational database. The chapters on hierarchical and network databases have been relegated to web add-ins. And you know how much the students go out and look at the extra stuff in the textbooks when they're going through this. It's a problem. And finally, we have data support operations. The idea that you can just start your data management up and let it run without maintaining it regularly is absurd. And again, most organizations only have some knowledge in this area, and it's of limited value. Now we've got some other things that are coming along here where we talk about big data, and we're getting some courses in there. Some of the courses have gone in there. It's a lot of fun. What I like to do, though, is tell people it's kind of like Maslow. Most of you remember Maslow from high school and things. If your food, clothing, and shelter needs are unmet, you are unlikely to be sitting down and doing whatever self-actualizing activity you do at night, whether it's poetry, writing, music, or et cetera, et cetera. In the same way, data management has the same sort of storage process, where if we look at these 5 levels of data management practice, and they are, by the way, interlocking, so they are only as strong as the weakest link in that particular chain, then all of the fun stuff that everybody wants to do, the sexy stuff, data scientist is the sexiest career out there right now, was said yesterday, and we get a lot of people that are looking for it. You can do this. All the things in the green there you can do. But if you do them without building the proper foundation, it will take longer, cost more, deliver less, and present greater risk to the organization than if you first put in place good data management practices at the foundational level. Now, I mentioned the CMM before. Most of you are familiar with this. In practice, everybody gets 1 point for showing up, 2 points if your processes are documented around there, 3 points if there's anything written down at all, 4 points if they are managed, and 5 points if periodically the group sits down and says, how's it going? Can we improve on this existing process? So by managing the 5 components of data management on the left-hand side of the screen, sorry, your right-hand side of the screen, again, these are the 5 we had before, for these levels, I can now go back in and give an objective, quantifiable, verifiable assessment of how this works. Let me give you an example of one I gave to one of our airline customers. We said, you're a 1, 1, 2 2s, and a 1. And of course, most of the people in the room said, so what? And I said, here you are against the other airlines. And they went, oh, they don't know what a 1 is or a 2, but they know they are the 1s, and the competition, in this case, is the 2. And they do have an idea. This is a quote from somebody at Boeing one point many years ago, so I can say it now. Go and do our survey after you've done Airbus. He gets it, right? They want to know what Airbus looked like so they could know how to compete against them. Again, you can look at these things and see where the challenges are, where organizations are looking at. This is the entire insurance industry that I recently did for the Insurance Data Management Association here. The average insurance company doesn't have repeatable practices. This talks about the problems that we have when processing things in that environment. Here's another set of measurements. This is since big data, if you will, has started, and the answer here is things have not measurably improved since we've started doing big data. So we're not doing big data any better than we did small data before. I like that. We've all been doing small data up to this point anyway, right? Here's a really astounding statistic, though. This is a group of data management professionals that we've surveyed year after year for a number of years. And the question was, are you leading in green, involved in yellow, or not involved in at all efforts that are going on in your organization? I'm not sure how you can do data quality without involving data people, but apparently a third of the organizations out there are trying to do it. Now, maybe they're already listening to all of us and saying it's a business function and we don't need to involve the IT folks, but I don't think that's really the answer on this one. So when we look here, what we can see is that largely data management investments corporate-wide are ineffective. 10% return a positive return on investment, 30%, including that first 10%, achieve some return, and 70% achieve little or no return on investment at all. So when management says, I don't understand what those people in the corner are doing, and cuts them off through reductions, layoffs, et cetera, and things don't get worse, it must have been the right decision. We all know, again, in this room, that is not the way we want people to think about this. Here's another astounding statistic. Since 1981, it's wonderful to be able to go back. This was actually an IBM-sponsored study that we did back in 1981. At that time, the percentage of top data managers that reported directly to the CIO was 74%. In 2007, when we reran it, it was 43%. And the percentage that were reporting 3 levels below has increased dramatically as well. So again, this eye of the IT has been pushed further and further down into the bowels of IT and further away from the people who are making important decisions about what we're supposed to do with this. So question comes up, what do we teach knowledge workers about data? By the way, the definition of a knowledge worker is somebody who works with data, right? So what percentage of knowledge workers work with data? 100% of them, and none of them are taught anything about it as a practice in college and university. And even in business schools, we teach some of the people who are never going to be accountants a bit about accounting, a bit about HR, a bit about finance, a bit about other types of activities that are important organizationally. In fact, if we really think about how our curriculum are set up, what we really teach people about data in the undergraduate curriculum approved by the ACM standard curriculum is they get one course on how to build a new database. Now, why you would take the most inexperienced people and put them on a new project is really beyond me at all. So the question of if 80% of IT expenses are working in existing legacy environments, why don't we teach them a little bit about that? They'll be a lot more useful to people as they come forward. Again, I'm seeing some heads nod here, so I'm not the only one that's sort of questioning that particular piece. Data are an organization's sole, non-depletable, non-degrading, durable strategic asset. And we use the word durable in there. The accounting people pop up and say, oh, we treat durable assets differently than we treat other assets in our organization. Maybe we should think about data looking at that as well. So I've talked a little bit about this. You guys all know the data volumes are increasing. I just love this particular one. 8.5 billion devices connected to watch the summer games. It's a phenomenal amount of coordination that goes on here. And of course, you all know this as well, which is that flash drives are replacing and cheaper than the old spinning hard drives that we used to use, which means that we can do a lot more capability-wise with these things than we've ever had before. It means we've broken through the barrier of the hard disk transfer and the transfer to memory. We can now make memory almost infinitely large, and we can also make disks almost infinitely large as well. And that does make a difference. Finally, some of you are familiar with the von Neumann bottleneck. The only way to make things faster in the von Neumann paradigm was to miniaturize things. We're approaching the limits of our ability to miniaturize things. So we now have to come back and say what happens, and Michael Stonebreaker did us all a wonderful service by looking and saying the average database is 4% efficient. You wouldn't want your furnace to be 4% efficient. Now, what that means is the opportunity for big data is marvelous, but it is a big sum game. We're doing trade-offs in all of these. So if we eliminate things like locking the records and doing other things in there, we can do some amazing things by operating these trade-offs, but our management doesn't understand this and they don't know what the trade-offs involve. So we collectively have to do the educational work to get them out there. Again, you've seen this probably before. This is a trade to exist in the EU has to exist for half a second. So somebody took a snapshot of the Johnson & Johnson stock for half a second. In a half a second, it was 1,200 orders and 215 actual trades that went on. This is a map showing how all that occurred in that process. If you're interested in these things, they're out there on YouTube. But this is where most organizations then are ending up with their data management efforts. It's a big, big challenge for them. So the diagnosis is pretty straightforward. I'll give you a very simple one we did out at Walmart at one point in time. Question was, why is infant mortality so high? And the answer was malnourished mothers. And we said, why are mothers malnourished? And the answer was substandard biology education in high school. And we said, well, why are the biology programs substandard? Because the biology teachers apparently had poor education. So why do we have poor high school biology teacher education? The biology profession apparently was unaware of these consequences. Now, how long is it going to take to fix this problem? We're not going to measure it in months and quarters, are we? We need to educate a new generation of biology teachers who then go out and teach a new generation of mothers who then go out and have babies that will be less malnourished. Unfortunately, we're in the same portion here. We have so many organizations that don't understand the role of data in IT, and consequently, they aren't able to focus on these improvements in this area. There's a lack of recognition by the system. There's not even an understanding at the C level that they don't know. They don't know what they don't know. So this also is a long-term, multi-generational problem that we're going to have to come back and address. Now, the remedies that I'm suggesting here, and I'm not the only one that's thought of these things, Dyson did a great job of this. We talk about bits. There's two of them, differences in space and differences in time. And the logic we've known since 1617, we could do zeros and ones and make a program for everything out there. The structure bits vary in time, but are vary in space, but are invariant across time. These are the memory. And the sequence bits vary across time, but are invariant across space. These are the code. We've had an awful lot of focus on the code, and now it's time to put some effort back into the data component on it as well. Fred Brooks, who also is the person who observed that adding more people to a late IT project makes the project louder, later. So you'd think the surge in IT is going to fix this healthcare.governor thing, government thing? Show me your flowchart and I'll conceal your tables and I'll be mystified. Show me your tables and I won't need your flowchart, it'll be obvious. We've known about these things. Again, data as an economic asset is very, very straightforward. What we need to do is start thinking about getting away from an application-centric development perspective. It's reasonable to see how people got into this. They started out with strategy and we make some goals and objectives. The goals and objectives then drive specific systems projects. It's a very natural process. It makes sense. And yet when we do this, we then start to add in network and the data becomes an afterthought in there. I'm going to be very silly and pick on SAP for a second here because it's an IBM conference, right? If SAP becomes the answer here, every conversation from this point downwards becomes about how SAP does things, not about how the organization needs to do things. It's a problem. It makes sure that the data is formed to the applications and not around organization-wide requirements, that the processes are narrowly formed around the applications and that data reuse is almost impossible to do here. Some of you remember the game of Twister. You start out with these legacy systems, whether you're building them in Agile or any other move, they end up with their own little stovepipes of data, and we need to tie them all together. And you win the game of Twister by not falling down. That's a very low standard, isn't it? So the change that makes a little bit more sense here is to say, let's take these goals at this level and talk about information-wide assets that we need to develop for our organization. The average organization maintains their customer data in 17 locations. If you know anybody that's doing less than that, tell them they're above average. Again, not a terrific message to take home. This means we can now have the network and infrastructure and systems and applications conversations conforming around the data needs of the organization. Another thing that we do have to admit as a profession is that software reuse is virtually at zero. When you measure it in the gross measures, go out there, you'll see a ton of papers on doing this. We are not reusing software, but we need to reuse data. And so let's start putting the focus back in where it should be. This means that we can now start developing the information assets from an organization-wide perspective, that the systems and process flows can complement the organizational perspectives, and that we can maximize data reuse. I'm working with a customer right now that is going from a mainframe here to mobile. They're even skipping the internet, which means their system design is they're designing a bunch of data objects here and pushing them directly out to the mobile. They're skipping an entire set of infrastructure that other organizations are burdened with, and they're going to have a significant competitive advantage in the very near future.
You won't read my technical report, so I summarized it in this complicated slide. If you stare at it long enough, you will either experience the illusion of understanding it, or be too embarrassed to admit you don't. Do you have any questions to betray your ignorance?
I have a question. Is the triangle thing mad at the tube?
If you didn't hear it, it says, the pointy haired boss says, is the triangle mad at the tube? So we've started out by trying to put somebody in charge of this. We originally called them the data processing manager, and that made a lot of sense. Now we call them a CIO. Everybody wants to be a chief. Nobody really wants to be a manager as we work through this. And yet when we look at what's going on from a chief perspective, when we talk about a chief in an organization is the head. Chief financial officer doesn't do the books. The chief risk officer doesn't test software, and the chief medical officer of organizations doesn't do surgery. They're focused on strategic things. When we look at what our CIOs have been asked to do, and this is an analysis of what CIOs have been advised to do and what CIOs have listed as their top 5 priorities. So these are the sources, and here are the results. It's just a lot. We're asking them to do an incredible amount of things, and if we want them to do more with data, something else has to drop. There's no other way around it. So the advocation here is for saying, first of all, CIOs aren't the ultimate authority on organizational data assets. They aren't able to devote sufficient time and attention to what needs to happen there. They don't have the requisite expertise. And finally, they're not organizationally situated in order to do this. Because data is different than systems development. Systems development is a creation-oriented process where we are creating organizational capabilities where those organizational capabilities didn't exist previously. Data, on the other hand, evolves. And because data evolves, it needs a separate development process that must precede, is external to, and separate from the system development activities. Again, it's a durable asset. We can't measure data evolution in 90-day increments or 2-week sprints. And the only alternative to this when you're doing Agile is to create more data silos. So a question that we get is, how do we speed Agile up? And the answer is, don't let an Agile project start unless you have the data requirements 100% specified by a very easy measure. Show me which data elements you're going to reuse in this project and show me which ones you need to create. If you don't do that, you don't have a good idea of what your data requirements are, and consequently you shouldn't be spending any money on software at all. So at least for the near future, we need somebody whose focus is 100% on our sole, non-depletable, non-degrading, durable strategic asset. The same way as we have other assets managed in our organizations. That individual should coordinate and, more importantly, be a gateway to IT development projects that go forward. And when the data requirements are set and ready to go, we should then move forward. And when they're not ready to go, we shouldn't let those projects move forward. I guarantee you we'll produce better results. IT doesn't feel the impact of poor data management. They don't know how to get the business rules. We call them business rules because they're over on the other side, right? IT does not control the access to the subject matter experts that we need to have, and only the business can competently assign the business values that we need to have in order to do that. Besides that, CIOs are really slammed already. They've got a lot on their plate, and they do a great job with what they've got. So it's an appropriate division of labor to have the data part report to the business, but it means we need to educate the business people that are involved in it. And many of you are familiar with the DAMA Book of Knowledge, the DIMBOK. Bad name, I'm sorry. What I would take is the DIMBOK if Peter was running the world, and I would have these 2 sections I just showed you there, data development and data operations management report to IT. These 2 functions here report in to both IT and the business, metadata management and data security, and the rest of the functions on this diagram would become business functions, which means we need to target our education, not just at our computer science, our STEM curriculum and things like that, but to our very business curriculum, to everybody out there, science curriculum, et cetera, give them a course on how to do this. When you look, these scientists are spending 80% of their time spending with Excel spreadsheets and trying to figure out access databases. Let's give them the knowledge and skills, abilities to do what they need to do, which is the thing they've been trained to do on this. So within the curriculum, we can look at a course that we're looking at implementing at VCU that would be required of all undergraduates to learn a course in data. We look at it from 5 perspectives, from an outside person all the way up through an aspiring data scientist type individual. And that there would be 2 additional courses. This is just within the existing structure to try and make some changes. And the one key here is that there's some things that are mandatory. If we don't do metadata management right, for example, we're not going to be able to build data warehouses properly. So we look at the mandatory pieces and we look at the optional pieces, and separating those 2 out, I think, is going to get us where we need to go. So anyway, that's my bit. I'm supposed to move this, and you're ready?
Yep, we're ready.
All right, good.